Question 10, Worksheet Work Power Energy. Diagram shows the vertical cross section LMN of a fixed smooth surface. M is the lowest point of the cross section. L is 2.45 meters above the level of M. N is 1.2 meters above the level of M. A particle of mass zero point 0.4 kg is released from rest at L and moves on the surface until it leaves it at n. Find the greatest speed of the particle. Okay, so it got released from rest here. Its greatest speed will be here because in this direction it has support of gravity, and in this direction it loses that support. So here the speed would be maximum. So we have to find the speed at v. Sorry, the speed at m. Okay, so greatest speed would be at m. I'm going to use the energy conservation formula, which is work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. Okay, this is just a particle. It's not a car's engine. There's no driving force. Zero. Plus loss in energy. Clearly, potential energy is being lost since the height is decreasing. So at m, the loss in potential energy will be mgh. This would be PE, loss in PE. Okay, so that would be m is 0 0.5 times 10 times height between L and M is 2.45 is equals to work done by resisting force. There is no resisting force mentioned in this question. Again, 0 plus gain in energy, which is gain in kinetic energy because it started from speed 0 and we need to find the speed at m. So plus half m bigger V minus smaller V's individual squares on them. So half times 0 0.5 times the bigger V is x squared minus the smaller V at L was 0. Okay. Now you solve this. So the formula actually becomes, since this is 0 and this is 0, the formula, sorry, this is 0. The formula becomes loss in PE is equals to gain in KE in the absence of driving force and resistance. Okay, now you solve this for x, which would come out to be 7 meters per second. Okay, so the speed here is 0 and the maximum speed here is 7. Next, it says find the kinetic energy of the particle at n. Okay, so we now need kinetic energy here. Let's look at this region. Let's apply energy conservation formula here again. Work done by driving force, 0, plus loss in energy. Kinetic energy will be lost because here the speed is greatest and here the speed would be slightly less. So half times m times bigger V would be at 7 at m, 7 square minus smaller v, let's call it u square or whatever you want to call it, un is equals to work done by resisting force, no resisting force is mentioned, plus gain in energy. Gain would be the potential energy gain since the height is increasing. So m g h. Now you move it around. If I make u the subject, comes out to be 5. But the question is asking the value of kinetic energy at n. So we have to do half m 5 square, which comes out to be 6.25 joules. Since they had asked for the kinetic energy at n, so it would have been better had we made this the subject instead of making u squared the subject. So then we would directly get 6.25 instead of getting 5 first as the value of u and then using half mu squared. Okay, anyway, next part is the particle is now projected from n with a speed of v along with surface towards m. Find the least value of v for which the particle will reach L. Okay, again, now the particle is projected from here and it will follow this path and it needs to go back to this point where it came from. And the question is asking what would be the maximum value of V that we need, sorry, the least value of V that can be taken here. Okay. Since there is again no resistance in mentioned in the question, and we know it started from 0 and this was 7 and this speed was 5. Now, in the reverse direction, if the particle needs to reach back to the height of L, it needs to start with 5. So, at least if the speed will be 5 at n, only then this particle will reach L at the top. Otherwise, if it's even slightly less, it won't reach L. But this is only true in absence of resistance. So you will write that the least value of V for which the particle would reach L is 5 because of absence of resistance.